So far the problems we've done in this section all have the plus c in the end. There's nothing more we could do with that as far as simplifying. But this problem here, we actually have some additional information that's provided, and that's going to allow us to actually find the exact value for c. So if they don't give you any of this, then you're not going to be able to find that, and you got to put this plus c only. But in this one we're actually going to solve it. So when it says solve the initial value problem, what is it asking for? They want you to find the original functions. They want you to find a y of x. So one thing that we should know about this, I'm going to do this off on the side over here, is if I take the antiderivative of dy dx, okay, that actually gives us y of x as a result. So by doing so, that's what we're going to do here. We basically take the antiderivative of both sides, and we know that that's going to give us a y of x. So let's do that on this one. We're going to take the antiderivative of both sides, and we are going to put a dx here. So whenever you take the antiderivative, we have this symbol. You need the dx to go with it, and then this part's going to turn into y of x. This part we can take the antiderivative using the inverse power rule. So we have 6. We're going to raise the power by 1, divide by the new power. We also have a plus c on that one. So I have y of x equals 2x cubed plus c. Now normally I would have stopped here. We wouldn't have had any more information, and that would have been my final answer. But they give us this information, y of 0 equals -1. So because of that, we can actually plug that information in here, and we can solve it. So this means that y of 0, the -1 is going to go in on the left-hand side. The 1 inside is always going to be your x value. So here's what it looks like. We have -1 equals 2 times 0 cubed plus c. So again, -1 goes in on that side, 0 goes in for the x. And then when we solve that, we get -1 is our c value. So now we know what the exact function is going to be. Y of x equals 2x cubed, and then we're going to put -1. Notice that if I take the derivative of this, if I do dy dx, 3 comes down, I get 6x squared. I do get the original one, and also because we set it up this way, we know that this will go through that point, 0, -1. Okay, this time they're giving us the second derivative. So we're still going to do the same thing. We're going to take the antiderivative of both sides. Okay, we're going to do that. So the question is, what do we get when we take the antiderivative of the second derivative? Well, we're actually going to get the first derivative. Okay, so when we do that, that's what we get on the left-hand side. We're going to get dy dx. So in order to get back to the original one, which is what they want us to do here, we're actually going to have to take the antiderivative twice. We did it once already to get dy dx, and then once we get that exact function, we'll take the antiderivative of that one, and then that's going to allow us to get back to our original y of x. Okay, so we did the left-hand side. We have to do the right-hand side. This is going to be the inverse power rule, x cubed over 3, and then don't forget the plus c there. Now we're going to use this information here in order to find the exact c value. We have to do that first before we take another antiderivative. We need to find out the specific c value. We're going to use this. Now the dy dx notation is exactly the same as the y prime notation. It still means the first derivative. So 6 is going to go in here. And then this is 0 cubed over 3 plus c. We get 6 for your c value. That means that my dy dx is equal to x cubed over 3 plus 6. That's our specific first derivative here. Now that we have that, we're going to take the antiderivative again to get back to the original function. So we're still going to do this. We're taking the antiderivative of both sides. This one I'm going to write as a 1/3 times x cubed. And don't forget the dx you need there for the correct notation. When you take the antiderivative of this one, you're going to get the y of x. This one over here, we have a 1/3 x raised to the power by 1, divided by the new power, and then this will just get you a 6x, and you have the plus c there, which means that y of x is equal to x to the 4th over 12 plus 6x plus c. But we're not done yet. We still want to find the exact c value, and we can use this second piece of information they gave us, the y of 0 equals 3, and I'll do that over here. So I put the 3 in for the left hand side, so 3 is going to equal, I put zeros in for the x's, 0 to the 4th over 12 plus 6 times 0 plus c, and that means that we get 3 as our c value. We're finally ready to write our final answer here. So we have y of x, we'll just put in a 3 for the c here. Y of x equals x to the 4th over 12 plus 6x plus 3. And this will be my final answer. So again, solving an initial value problem means you always want to go back to the original function. That's our answer.